This is a short video on determining in a long list the relative melting points or boiling points of a large bunch of different substances. So let's take a look at all these guys here, right? The best way to do this is sort of categorize them out. Now, as you might recall, networks have the highest melting points and boiling points. Molecular substances are the lowest, and the metals and ionics are in between. So if I was going to knock this thing out like super quick, I'd look for the network first and the molecular substances and the ionic. And if I can identify them, then I can order them. So right off the bat, I see I've got quartz. This is a network. I know that's going to be number one. So no matter what happens, that is the top of my list. I got silicon dioxide. And then I'm going to circle all the molecular substances because they're going to be at the bottom. So I've got CH4, H2, H2O2, and HCl. And the other three substances, I've got two ionic substances and one that is a metal. And that's going to make it very easy for me to order these things. Well, what I would do is, let's start at the bottom and work our way up. So, if we want to have a molecular substance with a low melting point and low boiling point, we want it to be a non-polar molecular substance unless it has a very large molecular weight. I picked four substances which are kind of close. Not exact, but close. At least they're in the low range. So the molecular weight of CH4 is 16. Hydrogen, it's 2. These are approximations, obviously. HCl is 36.5. And H2O2 would be 34. Now, of those four substances, two of them you should recognize as being nonpolar molecular substances. CH4 is tetrahedral with the four substituents around it being exactly the same thing, hydrogen. If they were different, it would be a polar molecule. See exam question 3C, that half of you, no, 90% got wrong. CH4 is nonpolar and so is hydrogen. Now, so we can now say those two guys are probably going to be the ones with the lowest melting points and the lowest boiling points. And at that point, we can look at van der Waals forces and molecular weight. Now, neither one of these things has like a lot of branches, so we're not comparing things with in terms of their like shape. Like a big branching molecule will tend to have weaker van der Waals than a straight one, where there could be more interactions between adjacent molecules. So we can put hydrogen all the way at the bottom because it has the lowest molecular weight and is the least polarizable and would have the smallest temporary asymmetric distributions of electrons. So we can put the hydrogen all the way down here at the bottom and the CH4 above it. Now, of the other two substances, both of these are polar substances. The structure of HCl is H and then the Cl, right? So that's and that it clearly has a dipole. This is a partial negative here and a partial positive here. And you get H2O2, which has a structure like this with an O and an O and an H, and it's got tetrahedral Lewis geometry around each of those oxygens right there, so you get those kind of bent shape there. And the oxygens, and in this particular case, the oxygens are pulling electrons close. This is also a polar molecule. However, because it's got oxygen covalently bonded to hydrogen, it's capable of hydrogen bond. So while HCl will only have London dispersion forces and dipole-dipole interactions, the hydrogen peroxide will have London dispersion forces, and it will also have H bonding, which is a specially strong type of dipole-dipole interaction. Therefore, if I'm going to do the next one up, I would be HCl and hydrogen peroxide, which is a lot like water and has hydrogen bonding, and because it has a similar molecular weight to HCl, would have a higher melting point and boiling point. Now, what's left? Well, we've wiped out this entire section right here. We're dealing with two ionic things and the metallic thing. Now, the reality is metals and ionic things tend to overlap. However, in this particular case, metals in general tend to have lower melting points. That's why some of them melt at temperatures like gallium melts at your body temperature a little bit less. You can put it in your hand and it will melt. Mercury melts below your body temperature at room temperature. And iron melts somewhere. I have no idea exactly, probably about 900. Either way, metals tend to have lower melting points than ionic compounds, so I put the metal next, although there are obviously some exceptions to that. And now I'm down to the two ionic compounds, and now I have to look at the crystal last. Now, the big thing that you look at first is you always look at the charge difference. And if the Coulombic forces are greater, it tends to have a higher melting point. So since calcium is a +2 -2 and sodium is a +1 -1, we would assume the calcium oxide would be here and the sodium chloride would be here. If it was the same thing, like if you had, let's say a KBr would go down here because K is +1 and Br is -1, but they have a larger radius, and so in that formula, in the denominator of last energy, KBr would have a lower last energy and therefore would have a lower melting point and boiling point than NaCl or calcium oxide. Remember, charge difference is more important in terms of how the formula plays out. So this is your order: network, ionics, metallics, then you have molecular metals, okay? Then you have molecular things. The things at the bottom tend to be things that have just London dispersion forces, and then you have something with a dipole-dipole interaction, and then you have something with hydrogen bonding. Again, molecular weight plays a big part here in these four at the bottom. You know, if this was, let's say, something like, C16H47, it might have a melting point that's higher than even H2O2, probably would, because London dispersion force can get very strong when you have larger molecules. Right? So that's really an important thing to be aware of. The London dispersion forces, just because something nonpolar does not mean it's a gas at room temperature. All right, hope that helps.